over r squared. And that will give you the 1/3. That gives you the 1/3. So if you put V, 4 over 3 GH here, 4 over 3 GH, right? 4 over 3 GH. So we have 4 over 3 GH, and we have 1/2. Remember, the other half is here in the I, because I is 1/2 mr squared for this object. The 4 and 4 cancels out, and you get 1/3. Got it? This is the type of question which is in the multiple choice and is in the free response. In the multiple choice, I only will ask one question eventually. So if I give an object rolling like this, I can ask for the acceleration, I can ask for the speed, or I can ask for the coefficient of friction, one question. But in the free response, I will ask for everything, somehow. Except that I will give any object. Question number 2. The last topic on rotational motion is momentum. So we finish with kinematics, dynamics, and energy. The last topic will be on angular momentum. And with that we finish, for the most part, this will be, I will say, 2/3 of the test, of the next test. Angular momentum. Angular momentum will be very simple. We won't extend in this topic. I will explain, and I will explain the law of conservation of angular momentum and how to find the angular momentum at a certain point. By the way, before finishing with energy, you can have the rod rotating about the end, and in the previous part, I asked for the acceleration initial, alpha, and A initial, and at an angle. That was in the previous class. This was the center of mass rotates to here. And I can ask for the alpha at this at an angle, which I ask. And the acceleration at the end, I have to give the point. But also I can ask, let's say when you have a rod, I can ask, find the velocity of this point, or the center of mass, or omega. I can ask for omega or for V. And in order for that, you have to use energy. So you have the rod and you want to find the velocity here. You have to use energy because the acceleration is not constant. You cannot use the Newton laws and big three. You have to use energy when the rod is rotating. Because the alpha is not constant. You cannot use kinematics and Newton laws. You have to use energy. But energy is very simple. Let's say that I ask, this is rotating with respect to the end or with respect to any point. Remember that the only thing that will change is the moment of inertia. But you have to use the parallel axis theorem. For example, I give the length of the rod, and I give the mass of the rod, and I can ask, find omega when the object is like this, vertical. And find V at the end, at this point. So you use EI is equally final. It's like a pendulum. At the beginning, what is the energy? With respect, you only look for energy potential, you only look at the center of mass. How much is the center of mass on top of the lower point of the center of mass? How much is the center of mass on top of the lower point of the center of mass? So when rotate like this, how much? In terms of L. L over 2. Everybody can see that? So this start here, finish here. The question is find the velocity of this at this point, the angular velocity. So how much is this point below this point, at this point below this? How much of a ruler? Half. Everybody can see? L over 2. So the potential energy, what will be? E initial is only potential. At the beginning, start at rest. mg what? What is h? L over 2. At the end, what type of energy has the object? Kinetic. This object, look at this point, is rotating or translating. This is the axis of rotation. Rotating. Everybody can see that it's rotating, not translating. When you don't see that the axis of rotation is moving, it's rotating. So, what type of kinetic energy then will have the object? Kinetic, which will be 1/2 I omega square. I am looking for omega, but I need to know what is L or what is I.